Hello students, welcome back to College Algebra. I want to look at a problem from section 3.4, which is graphing polynomial functions. What we have is p of x equals x minus 3, that quantity squared, times x plus 1. So let's go ahead and find the y-intercept. We find the y-intercept by plugging in 0 for x. So if I plug in 0 for x, let's see. 0 minus 3 is negative 3. Negative 3 squared is 9. 0 plus 1 is 1. So we have 9 times 1, which is 9. So written as an ordered pair, the y-intercept is 0, 9. Now, what about the x-intercepts? Well, the values of x that make this function equal to 0 are easy to find because this polynomial is given to us in completely factored form. We're really using the factor theorem. You should realize that. So, the x-intercepts are 3, 0, and also negative 1, 0. Right? The values of x that make the polynomial 0 are 3 and negative 1, because for the factor x minus 3, if x is equal to 3, x minus 3 is equal to 0. And for x plus 1, if x is equal to negative 1, x plus 1 is 0. Now what we have to talk about is the behavior of the graph at the x-intercepts. Notice the factor x minus 3 is raised to the second power, which is even. So what that tells us is that at the x-intercept 3, 0, the graph is going to bounce or reflect. So we're going to have a reflection happening at 3, 0. And at negative 1, the graph is going to pass through, because the factor x plus 1 is raised to an odd power. Whenever your factor is raised to an odd power, that means that corresponding x-intercept, what's going to happen is the graph is going to pass through. And if the multiplicity, remember multiplicity, that's the number that this factor is raised to. If the multiplicity is even, like it is in this case, you have a reflection. Okay. Now there's something else we need to talk about, and that is end behavior. See, all these things work together. See, if you were to expand this out, what you would get is a third-degree polynomial with a leading coefficient positive. So it's just going to, the end behavior is going to be the same as the end behavior of y equals x cubed, which we know is down, up. Okay, so we have a grid given to us. We have to draw in the axes. I hope that's not too much trouble. All right, the y-intercept is 9. All right, there's the ordered pair 0, 9. There's the point 0, 9. We have the x-intercept of 3, 0, 1, 2, 3, and negative 1, 0. And so I have 3 points on the graph. I know what the behavior is at each x-intercept, and I know the end behavior. Now, if you want a really nice graph, you have to put in some intermediate points. Okay? So, notice this x-intercept right here is negative 1, 0. And what's supposed to happen is the graph is supposed to pass through at that point, and that agrees with everything that we know. Right? Remember, look at the end behavior, down, up. Look at this y-intercept. Right? So what's going to happen is the graph is going to pass through this point and go up to the y-intercept. And it's going to turn around at some point. And then it's actually going to turn around again at 3, 0. So I know that 3, 0 is going to be what we call a local minimum. We'll see that. Now, somewhere around here, there's going to be a local maximum. It may not necessarily be at the y-intercept. If you really want a nice graph, you have to pick some intermediate points, but we'll just do our best. Okay, the main thing is to get the behavior correct. You know, the end behavior, which we have, the correct x and y intercepts, and the behavior at the x and y intercepts. Now let's use some technology to check what we have here. Our function again was x minus 3, the quantity squared, times x plus 1. Perhaps you've heard of Desmos. So what we're going to do is we're going to type in our function. Okay, what we have is y equals x minus 3, the quantity squared, times x plus 1. Right, so there's a picture of what the technology gave us, right? We have maybe you can see the y-intercept is indeed 9. We have an x-intercept of negative 1, an x-intercept of 3. Right here we have a local minimum as promised. So compare what the technology gave us with our graph. I think we are pretty close. Okay. So do some more problems from section 3.4, and then contact me if you have any questions.